Welcome back to my channel. In this video series, we will learn about logistic regression. Okay, so this video is going to be little bit theoretical, as we are going to understand some of the basic concept of logistic regression. And in next video, I will train the model using logistic regression. So this video is important because you should have some basic understanding about logistic regression before going to actually train a model on using that logistic regression. Okay. So logistic regression is basically uh, depend upon classification. We classify the output. Uh, what does classification means? Making predictions where output is a categorical value. Okay, so it's like too much bookish example. Let understand with example. So here you can see I have a data of diabetic people where the first column contains the blood sugar level and the second column contains whether the person is diabetic or not. Okay, so here you can see the output is divided into categories. First category is yes and the second category is no. Okay, there might be n number of categories, or suppose you want to like segregate your email based on like whether it's promotional email, whether it's spam, whether it's ham, whether it's personal email, or whether it's a work email. So that all classifications is possible using the logistic regressions. Okay, so in this series, we will cover topic like binary classification, what is sigmoid function, what is likelihood function, and we will build logistic regression model, of course, and we will also learn about what is odd and what is log odds. Okay, so the most common logistic regression is the binary classification. Okay, what do we mean by binary classification? As the name suggests, there is only two possible output. Suppose in this case only two possible outputs, first one is yes and second one is no. So there is only two output that is possible. Suppose we want to train a model to find out whether the email is spam or ham. So first category will be spam and the second category will be ham. So that will be also example of binary classification problem. Okay, I hope you are with me till this point. Okay, now let's talk about sigmoid function. Okay, so we use sigmoid function to map the range of input values between 0 to 1. And why we do it, and what is the practical approach, we will see while we train the model. We will practically see the use of these sigmoid function and the likelihood function, but for now let's understand what basically it means. So suppose we want to predict whether a student will pass or fail in exam based on their study hours. Okay, we can use sigmoid function to calculate the probability of passing the exam as a function of we can pass like study hours, and it will predict whether the student will pass or fail. Okay, so how we can write it? P equal to P equal to sigmoid x. And what is x? X is input variable. Okay, where x is input, oh sorry, spelling mistake, input variable. Okay, where x is input variable. So let's go ahead and see the formula of sigmoid function. So the formula of sigmoid function is 1 by 1 plus e to the power x. Okay, and where x is the input variable. Okay, if the value of p is greater than 0.5, we predict that student will pass the exam, or if the value if the value of the probability is lesser than 0.5, we can say that student has failed the examination. Okay, so how output is affected using this x variable is basically when x is large and positive, the output function approaches to 1, so the value will be remain closer to 1. And when it is like um, when it is a large and negative, the output varies between 0, so it lies around between like 0 only. Okay, so let's go ahead and see some of the graph of the sigmoid function. So I will take help of Google here, and we can like search for sigmoid function. See, I have already browsed it for the formula, and we can see the graphs here. So you can see the graph is something like S-shaped curve. Okay, the graph, you can see the graph of a sigmoid function is a simple S curve. Okay, so how to build this graph and how to like analyze the data, we will see later on. Okay, so next let's talk about likelihood function. Okay, so likelihood function measure how will be a model parameter, how will a set of model parameter explain the observed data. Okay, what does it means, like when we are training a model, when we train a model, we pass certain parameters, right? So what will be the best value for that parameters, that can be decided using this likelihood function. Okay, so suppose in our previous example, suppose we have a data set of 100 student and we want to calculate the probability of passing the student based on their study hours. We use like sigmoid function as activation function, and the model parameter in this case will be the coefficient of the logistic regression model. Okay, which we can achieve using likelihood function. Okay, so which measure how will model fit to the observed data. Okay, and we can also use optimization techniques such as gradient descent or Newton method, to find the values of the coefficient that maximize the likelihood function. Okay, the sigmoid function is used to get the probability of the binary outcome, while the likelihood function is used to estimate the parameters of a model. Okay, I hope you find this video helpful in understanding this concept. Of course, there are like we will see in much detail when we do the practical session. So in next video, we will train a logistic regression model. If you have any question or comments, please leave them below. Don't forget to like and subscribe. Bye bye.